All right, we're going to solve by quadratic formula this time. So remember, this is kind of your go-to. If another method is not working out for you, this will work no matter what. It doesn't matter if your answers are real or imaginary. So I'm going to do an example of one of each. First thing you got to decide is what your A, B, and C values are. You're going to plug into the formula and go from there. Okay. So for this first one, our A value would be 1, B value -3, C value -10. Be very careful with your signs. Usually when somebody brings me a problem and they're stuck and it's not working for them, chances are a lot of the time it's one of their signs is wrong. They should have had a negative for one of these guys and they have it as a positive. Okay, so let's plug into our formula. We start with the opposite of B. So we always do the opposite sign of whatever that B is. So in this case, we're going to start with a +3. Plus or minus, and then we get that discriminant portion. So that's the b squared minus 4ac. So this for us would be -3 squared minus 4 times 1 times -10 all over 2 times 1. So we're always first going to take care of the discriminant and that denominator. So my discriminant, we're basically looking at +9 plus 40 would be 49. Remember, when you're doing that discriminant, if you don't put parentheses around that -3 value that you're trying to square, it's not going to have the right signs, which means you're not going to get the right discriminant overall. So just keep in mind that anything you square should end up being a positive number, okay? So that 49 is a nice perfect square, so we can just say that we have 3 plus or minus 7 divided by 2. Let me see if I can get rid of the glare. Well, that's a little bit better. So we can use this here to help us get our two real answers. So one would be 3 plus 7 divided by 2. So that's 10 divided by 2, which is 5. The other solution we would get by doing 3 minus 7 divided by 2. So that would be -4 divided by 2, which would be -2. So now I know that I cross the x-axis at 5 and -2. Okay. All right, second one over here. So we're going to do the same thing. So these are going to actually end up being imaginary answers. So we're going to determine our A, B, and C. So A would be 1, B would be 6, C would be 11. We're going to plug into our formula. So we're going to do the opposite of B, -6 plus or minus. We get that discriminant part. So the b squared minus 4 times A times C. So 6 squared minus 4 times 1 times 11. All over 2 times A, so 2 times 1. So we've got -6 plus or minus. We're going to get that discriminant. The denominator would become 2. So let's see, 36 minus 44 would be -8 for my discriminant. So that's kind of my clue there that we are dealing with imaginary solutions. So I'm not going to be able to get to, completely nice numbers like I did here. I do need to think about this square root of -8 and think about how it could be rewritten in a more simplified radical. Okay, so we have square root of -8. Since 4 goes into that, this would become 2i times the square root of 2, and that would be all over 2. Our final thing would be to kind of look at this -6, the 2, and the 2. Not what's in your radical, so not what's here, but if these three can all reduce by something, we should reduce them. Since they all can divide by 2, we're going to say our final answer is -3 plus or minus I times the square root of 2. So that would be my set of imaginary solutions. Okay, and that's quadratic formula.